In this video, I'll demonstrate how to create a one variable and a two variable data table. So data tables are used for what if analysis. In fact, if you go to the data ribbon, there's a section called what if analysis over here in the forecast group. You hit the drop down arrow, and there's three different tools, and the one we're going to do right now is called data table. And basically it's a way to look at a group of formulas, vary one of the inputs to those formulas, and quickly see the results of that input that's being varied on all of our formulas. So we're going to do it first for an auto loan, and then we'll do a break-even analysis. On our auto loan, we're buying a $25,000 car, $5,000 down, and this is our annual percentage rate, 5-year loan, 12 payments per year. So real quickly, what's the amount of the loan? Well, it's simply the cost of the car minus our down payment. What's our periodic interest rate? Remember, this is annual, so we're going to take that 4.5 and divide it by the number of payments per year. So we are doing a monthly loan. And well, then how many periods or payment periods do we have? Well, 5 years times 12 payments per year is going to give us that 60. So real quickly, let's calculate our monthly payment with the PMT function. Our periodic rate I've already calculated, so I'll select that cell. The number of periods is going to be 60, which I've already calculated. I'll select that cell. And the present value, the amount of money I have right now, is the $20,000. So I'll take that, and it's a negative 372 because the money's leaving my pocket. Now, what's it going to take to repay that loan? Well, we're paying this amount per month for how many months? It's the 60. So our $20,000 loan is actually costing me $22,000. And of course, calculating the interest to be paid, all I have to do, because that's a negative number, I can take this and add in the negative number, and that's the value of my interest paid. So now, one variable data table is basically, I'm curious what the interest would be, or the payment would be, the total amount to repay the loan and the total interest paid, if the interest rate, instead of being 4.5%, was 3.5%. What if it was 3.75? How about 4, 4.25, 4.5? You get the point. I want to vary one of the values that's an input to my formulas down here in the output area. So right here, I'm going to put 3.50%, and then I'll go 3.75%. I will select both of those and autofill down to 5.5%. And right here in this cell, I need to point to the formulas that I want to watch change based on this input that's varying. So I'm going to just point to those formulas and equal the payment. And then I will put equal the total to repay the loan, and I will put equal the total interest paid. Now, I don't have to do all three of these. I don't have to fill all of this in. I could just watch one, or I can watch more than one of my formulas in the output area. In this case, I chose to watch all three. So how do you fill out the rest of this data table? I will select all of my fields here, my inputs. That is the three formulas I'm going to watch, and the interest rate that I'm varying from 3.5 to 5.5%. Then you go what if, you hit data table. Now this box is not that intuitive. All it says is row input cell, column input cell. What it's referring to is the data that's changing, right, that I'm varying, the interest rate. Right now that is in a column, so I select column input cell, and it's basically asking over here in my original input and output, what value does this represent? And so the answer is the APR. So column input cell, you select APR, you hit OK. So that it's a little easier to read, I will format these values using the accounting format. There we go. So basically what it's telling me is my payment at 3.5% interest would be $363. If my interest was 5.5%, it's $382. And notice right here, 4.5%. Well, of course, that matches the value I already had in my original formulas. I can now see that the total to repay the loan varies from $21,830 to $22,921. And then, of course, the amount of interest I paid at 3.5%, you would expect to pay less interest. At 5.5%, it would be a lot more. Now, one thing I'll mention about data tables, if you look up here in the formula bar, it says table, comma, B4, but it has these curly braces around it, which tells you it's an array formula. And the point of an array formula, or the point I want to make about them, is you can't just delete a piece of that. I can't run over here. For instance, I decide, oh, I didn't mean to go to 5.5. I want to delete that. Well, you can't. On an array formula, you have to select all of the array, which would be all of these cells right here, and hit delete. And then basically at that point, you would just have to start over. If you didn't want 5.5%, I'd have to clear out that cell and then redo this. So one more time, I will select the formulas that I'm watching, the data that's changing, the thing that's varying. I'll go to data, what if, data table, and my data that's changing, that's varying, is in one column. So I choose column input cell, and that column represents the APR over here in the original input output area. So and there's my new values. All right, I'll show one more thing that sometimes students will do. Again, I'm going to clear this out by selecting everything. When you're typing your formulas, all right, so right here I've said 4.5 divided by the 12. Well, sometimes what people do, rather than clicking on the cell reference, they will type 4.5% in their formula. Okay, so I get the same answer. Nothing changed here. Everything's working fine. But when I go to do my data table, and I say that this column of data that's changing represents that APR, well, that particular cell is not actually being used in any of these formulas. And so when you hit OK, I get the same price all the time, because changing that cell is not changing anything down here, since I've what I call hard-coded that formula. So make sure when you're doing data tables that all of your formulas are referencing cells and you haven't hard-coded any of the values, because then the data table doesn't work. The fact that I'm changing that is not impacting any of the results down here. So real quick, I'll fix my hard-coded 4.5%, hit delete, and I'll reference the cell, hit OK, and now my data table works again. So let's do a two-variable data table. Now that you understand what a one-variable data table is doing, it's not that hard to figure out the fact that a two-variable means I want to watch two things change. In this example, I want to see the impact of my monthly payment if I were to change the cost of the car and the APR both. So for instance, let's go ahead and put the cost of the car right here. And let's say we're willing to buy a $20,000 car. I will make that accounting. We'll increase the, whoops, not quite that large. I'll drag that back over. And let's make this 21,000. I will select both of those values, drag down. And so we're looking at anywhere from a $20,000 to a $21,000 car. Again, I'll fix my formatting there. And the APR, we'll have less options here. Let's go 4%. Maybe we'll go 4.5% and 5.0%. And again, I'm going to take my format painter and so that didn't work so well, 4.0%. There we go. So I'm varying the interest rate, this time just the 3 different values, and I'm varying the cost of the car from $20,000 to $36,000. Now, the one difference between a 2-variable and a 1-variable, in the 1-variable, I could point to multiple formulas in my output area and see the impact of changing the interest rate. With a 2-variable, it's in this corner that I can point to only one formula, so I have to make a choice. What do I want to see changed, or the result of changing my monthly interest rate and the cost of the car? Well, in this case, the payment is most interesting to me, so I'll point to that. Okay, so in this cell it puts the payment. Now this part becomes similar in that I select the headings and which is the interest rate and of course the cost of the car. I go to data, what if, data table. Now this time it's a 2 variable. My row input cell, that's this part. That's the input cell, it's in a row, and it's asking over here in your original input area, what does that represent? Well, it's the APR. So this time the row input cell is B4, and the column, which is the data going up and down in the column, what does that represent? It is the cost of the car. So that column represents the cost, this row represents the APR, so I hit OK, and now I can watch the payment change. 4%, a low interest loan on a cheap car is going to be $276 a month. A high interest loan on a more expensive car is going to be $585 a month. So data tables are easy to create, and recognize that I can vary anything. In this example, I happen to have chosen the APR. I could have made it the down payment. What would my payment, the total to repay the loan and the interest paid, be if the down payment was $5,000, $5,500, $6,500, or whatever? The years of the loan, I could say, what if it was a 3-year loan, a 3.5, a 4, 4.5, 5? So the things that you vary are inputs to your output area, but it could be any of those inputs up here as long as they are represented in a formula down here. Now, one more thing I'll show you is sometimes you present these to somebody and they ask, well, what is that red 372 doing in the corner? They don't understand why that's there. And so to prevent that question, you can go home and under number, I'll hit that group icon there, the dialog box icon, and I'm going to go to custom. And right here, I can type in quotes P-A-Y-M-E-N-T. And then I hit OK. And it takes away that value and just puts the word payment right there. It doesn't change what's in the cell, right? What's in the cell is simply equal B12, but it's simply formatting what we see. And so I've forced it to show me the fact that it's the payment. Of course, it has that negative sign, which is a little bit annoying. Not sure how to get rid of that. But again, I'll just open the dialog box launcher. You go to custom, and in quotes, you type the thing that you want to replace the payment with. And so in this case, it's the word payment. So I hit OK. Another common place to see data tables used are on a break-even analysis. So in this case, we're building stand-up paddle boards. We've sold 330 of them, and we're selling them at $890 each. And so what's the total revenue? Well, you just subtract those two. Well, in most businesses, you have two types of expense. A variable expense that changes based on how many subs we sell or produce. And we have a fixed expense, meaning I have to pay these salaries and benefits whether I sell 1 or 100, right? It's always going to be the same. It doesn't change based on how many we produce. So let's fill out our variable expense, and the subs produced are going to equal, we're going to produce the same amount that we sell. So we're just going to point back to that cell, equal 330. Average material cost is 225. So then what's our material cost? Well, if we produce that many times that amount per sup, then we'll have 74,000 material costs. It takes $75 per stand-up paddleboard in manufacturing costs. So again, what will that equal? I take the 330 and we'll multiply the 75, and then finally, what's our total variable expense? We're just going to add up those two cells, that one plus the one. If it'll let me sneak in there, I'm just going to type it, so it's B13. So there's our variable expense. Here's our fixed expenses. So all I need to do is sum across those cells. And then what's our revenue? Well, we already calculated that right here, which is the 293. Our expenses are going to be the sum of the variable plus the fixed. How much net income do we have? Well, we'll just type equal, and it's going to be this cell minus the one just below it. I'm going to assume it also has a name, total expenses, so I can just hit the tab key and hit enter. So that's our net income. So the question becomes, how many of these subs do we have to sell where we break even, where our net income goes to 0? So of course I can type 310 and run down here and take a look, and I could type 309 and run down here and take a look, right? I could just keep trying numbers until I see this cell go to 0. But let's do something different. Why don't we do a data table that will help us figure that out? So what we want to do is vary the amount of subs sold. So maybe let's start with, what do we want to start with? Let's go 290 and we'll go by 5s. 295. I will select both of those cells. We'll drag down. Something didn't happen right there. Let's Control Z that. Somehow I have an equal sign on that 290. I don't know why we got that. So I guess I typed it. Now it should work. There we go. So let's go down to 360. I'll just stop there. Up in these cells are where I point to the things that I want to watch impacted by the change in the amount of subs sold. Again, we're doing 3, but recognize I don't have to do 3. What's our revenue going to do if we sell that many? So I could either point to this cell or that cell. I'll do this one just because it happens to be closer. And then what are our total expenses going to do? So I'm going to go ahead and point to the total expense cell down here. And then finally, what's our net income going to do? And I will point to the net income down here. So it's just an equal sign pointing to the cells that contain the formulas using our input variables. Now we fill in our data table. There we go. I go to the data ribbon. What if data table? Is it row or column? The thing that's changing in our one variable data table is in a column. So I click on column, and what does that represent? That represents the subs sold. So I'll click on that cell and hit OK. And there you go. You can see from 305 to 310, we go from a $50 negative net income to 2,900. So someplace in between there is our break-even point. Obviously, the cells up here were already formatted. I will run to Home, choose Format Painter, and now I can drag that across to make all of our cells look the same. Last example, let's do a 2-variable data table on our sub break-even analysis. So what are the things that I could look at in my 2-variable data table? Now obviously I have a title here called average price per sub. So I can vary 2 things. Well, one thing would be how many we sell, and the second thing would be what are we selling them for. I could also take a look at maybe my material costs. What if I were able to lower that to 215 or 210 or 205? And the other one is the average manufacturing cost. What if I could get that down to 70 or 65 or 60? All of those values are inputs into the rest of the formulas. So in my example up here, let's go ahead and we'll just vary these 2 values, the number sold and the price per sub. So I already have the number sold listed over here, so I think I'll just Control copy that, and I'll Control paste it right there. The price per sub, well, let's say, what if we lowered the price to 880? We'll go ahead and do 890, 900, 910, and we'll go 920. I'll just type it rather than autofill it in this case. So on a 2-variable data table, I can only watch the impact on one of our formulas, and it has to go into that corner. So I'm going to go equal, and because it's a named range, I'm just going to start typing net income. I'm going to see what happens to our net income when I change the number of subs sold by those amounts, and I change the average price by these amounts. So I'll now select that range of data. Notice I'm not grabbing titles or anything. It's just the values and the pointers to the formula. Back to data. What if data table? So this time, row input cell. This is my row input. What does that represent? It represents the average price per sup. The column input cell. This is my column over here in column I. What does that represent? The number of sups sold. So I hit OK. I'll scoot back over here. And there you go. If we sell the sups at 880 per unit, we have to now produce 315 of them in order to get into the black. If we sell them at 890, we get the same result as we had a second ago, where basically at 305, I'm darn close to breaking even. If we could sell them at 900, we'd be 0. Or 300, I mean, is right. There's a perfect break-even point right there. So there you go. That's what a data table does for you. It allows you to quickly look at and analyze the results of changing, in this case, 2 variables, given our current input and output area. Thanks for watching.